Test for convergence of a series. A series can be tested using the ratio test technique, sometimes called D'Alembert ratio test. The convergence of a series can also be tested using the comparison test technique. 1. Ratio test. Let summation un be a series and L equals to lim un plus 1 over un as n tends to infinity. If L is less than 1, then summation un converges. If L is greater than 1, then the series diverges. If L is equals to 1, then the test of the series summation un is inconclusive. That is, we cannot say whether the series is divergent or convergent. Example, test the convergence or divergence of summation 5 to the n all over n factorial from 1 to infinity. For this series, un is equals to 5 to the n over n factorial. Un plus 1 is equals to 5 to the n plus 1 all over n plus 1 factorial. That is replacing n by n plus 1. You know, from indices, a to the n times a to the m is the same like a to the n plus m. 5 to the n plus 1 is the same like 5 to the n times 5. You also know that n factorial is the same like n into n minus 1 factorial, n minus 2 factorial times up to 1. That means n plus 1 factorial is the same as n plus 1 times n factorial. Since n plus 1 minus 1 is n, that means un plus 1 can still be expressed as 5 to the n times 5 all over n plus 1 times n factorial. Now, lim un plus 1 all over un as n turns to infinity is equals to lim 5 times 5 to the n all over n plus 1 n factorial divided by un, which is 5 to the n over n factorial as n turns to infinity. Inverting the denominator and multiplying, we have lim 5 times 5 to the n all over n plus 1 n factorial times n factorial all over 5 to the n as n turns to infinity. Here, 5 to the n cancels, n factorial cancel n factorial here. We'll be left with lim 5 over n plus 1 as n turns to infinity. To look for the limit of this function, we substitute infinity in the place of n. We're going to have 5 over infinity, which we approximate to 0. Therefore, the limit of this function is 0. We know from the ratio test we said L was equals to this. Now, L is equals to 0 and 0 is less than 1. Therefore, this series from the ratio test converges. 2. Comparison test. Let's say we have two series, summation un and summation vn, where un and vn are positive sequences for all positive values of n. If summation vn is convergent and un is less than or equals to vn, then summation un is convergent. Roman 2. If summation vn is divergent and un is greater than equal to vn, then summation un is divergent. Example, by comparison test, find out whether this series converges. Solution. The method here is that from this series, we need to bring out two sequences, un and vn. All the time, we'll always take this parent sequence to be un. That is, un is equals to 1 over 3 to the n plus n. From this same sequence, we need to bring out vn. That is, vn is equals to 1 over 3 to the n. When bringing out vn, why did I ignore this n? Because to come out with vn, we consider only the most significant part of the denominator. And the most significant part is 3 to the n. 3 to the n is most significant because for all the terms of this series, at any value of n, 3 to the n will always be larger than n. That is, let's say n equals 1. We'll have 3 to the 1 plus 1, which is the same like 1 over 3 plus 1. Now, let's say n equals to 2. We'll have 1 over 3 squared plus 2. If you look carefully, you discover that these terms to the power n will always be larger than this term. That is, 3 to the 1 is 3, which is larger than 1. And here, 3 squared is the same like 9 plus 2. You see, it is larger than this other term. So that's why we say 3 to the n is the significant term on the denominator. And from that idea, the denominator is always approximated to the significant term, which is 3 to the n for this case. Now, summation un from n equals to 1 to infinity is equals to 1 over 3 to the power 1, that's 3, plus 1 is 1 over 4, plus 3 to the power 2, that's 9, plus 2, 1 over 11. When n equals to 3, we have 1 over 30, plus infinity. Summation vn from n equals to 1 to infinity is equals to 1 over 3 to the 1 plus 1 over 3 squared plus 1 over 3 cubed plus infinity, which is the same like 1 over 3 plus 1 over 9 plus 1 on 27 plus infinity. From the comparison test, we need to find out if summation un is convergent or divergent. If you look very closely, we can see that summation un is a geometric series. That is, un plus 1 all over un is equals to r, which is a constant. That is, 1 over 11 all over 1 on 4 is equals to 4 over 11, and the 4 over 11 is less than 1. That is, the series un is convergent. We can also observe that for all n, un is less than vn. That is, 1/4 is less than 1/3. 1 over 11 is less than 1 over 9. 1 over 30 is less than 1 over 27, and so on. Since un is less than vn for all values of n, then we can conclude from the comparison test that the series summation 1 over 3n plus n is convergent.